Hello, in this video we shall learn about gradient descent. In our previous video we have already learnt about linear regression. So let us relate gradient descent with linear regression. Talking about linear regression, it finds relation between dependent and one or more independent variables, and this relation is represented using a straight line. So if I have my x-axis and y-axis as such, where I scale it as 10, 20, 30 suppose, and over here suppose I have 5, 10, 15, and my data points are scattered as such. Okay, so now what linear regression shall output us? It finds a straight line passing through maximum of these points. Okay, maximum of these points, but it may give us more than one line. Okay, more than one line, and all these lines are the straight lines with the equation y equal to m1x plus c1. Okay, second line has the equation y equal to m2x plus c2. The third line has the equation y equals to m3x plus c3. So all the three lines have equation of straight line with different values of m and c. So the question comes, which among these lines would be best fit line? Okay, for that we should know what is cost function. In our previous video, we have learned what is MSE. So MSE stands for mean squared error. How do we find mean squared error? It's y minus y hat, which is error. We need to take square of it and we need to find mean of it. So this is our MSE. So this MSE is nothing but our cost function. This itself we shall call it as our cost function. Okay. So cost function is a mapping function which tells us the difference between our desired output and what our model computes. Okay. So our goal is to minimize this cost function as much as possible so that we can find out the best fit line. Okay. So what if we try all permutations and combinations of M and C to find best fit line? Is it feasible? No, not at all. It's such an inefficient way. So we use gradient descent. Gradient descent finds best fit line in an efficient manner using 5 iterations. Okay, so what gradient descent will do for us? It shall find combination of M and C such that MSE will be the minimum. Okay, MSE will be the least. So this is the job of gradient descent, to find the combination of M and C such that MSE, that is our cost function, will be the least. Okay, so we can say that gradient descent is optimization algorithm that finds minimum of a function. Okay, it updates coefficients, that is M and C, in linear regression. So before actually proceeding to gradient descent, let us see one example where I have a ball. Okay, imagine that I have a ball, and if the ball is placed on inclined plane at position A. Okay, so I placed my ball over here at inclined plane at position A. Now the ball starts rolling down. How long will it roll till it reaches a gentle plane where it becomes stationary? So my ball shall become stationary when it reaches position B. So similarly, in gradient descent, we have cost function. Okay, we have cost function that I shall plot over here. Okay, so suppose I have cost function that is nothing but my MSE. Let me plot it against M. So I have my cost function inclined as such. Okay, so in gradient descent, inclined is the cost function when it is plotted. So what is role of GD? Okay, what is role of GD? So role of the gradient descent is to provide direction as well as velocity of movement to attain minimum of function. What is my aim? My aim is to reach at this point. Okay, this is my global minima. So in order to reach to global minima, okay, how should I mean, how should I traverse? In what direction? With what velocity of movement? So that I can reach to minimum of the function. So this is done with the help of gradient descent. Let us further see the gradient descent. Okay, so these are the steps that we shall see mathematically. Okay, so initially we need to assume m and value for m and value for c. So let us imagine we can have either 0 or we can have 1. Okay, so those are random values. Okay, so let us assume m equal to 0 and c equal to 0. Then we require L. L is nothing but my learning rate. Okay, learning rate. We shall see further what is actually learning rate. Here, let us just take one value for it. Again, we need to randomly assign value. Okay, but let me tell you, generally, a smaller value is taken for better accuracy because this L controls how much the value of M or C should change with each step. Okay, so right now just understand that learning rate we have taken it as L to begin with. Okay, we will see further actually what is learning rate. Then after assuming the things, our second step says that we need to concentrate over the loss function. Now what is loss function? Again, it is nothing but my cost function. What is my cost function? It is nothing but my MSE. Okay, so let us jot out the formula for MSE. 1 upon n, summation I goes from 1 to n. Okay, what do I have further? Yi minus mx plus c, right? Actually, it is y hat. So what is y hat? I'll explore it further. It is nothing but mx plus c. So square of this, right? So this is nothing but my MSE. So in step 2, I need to go for derivative. Now why derivative? Okay, when I talk about the slope m, okay, how shall I define m? M is nothing but change in y upon change in x. Okay, change in x. So when I talk about derivative, I represent it as delta y upon delta x. That is a small change in y upon small change in x. Derivative refers to slope of a function. It refers to slope of a function. Now, what we do over here is we compute partial derivative of our cost function. Why to do this? Because it provides direction. Okay, direction, that means sign in which our coefficient value should move so as to attain the lower cost. So what is our further aim? We need to find the derivative of cost function with respect to m as well as c. Okay, so let us first of all do it with respect to m. Okay, so I denote derivative with respect to m as d by dm, or we can also say simply dm. Okay, so let us find the derivative of our cost function with respect to m. So it is 1 upon n. Okay, summation I goes from 1 to n 2 into yi minus mxi plus c into. Now I'm computing with respect to m. So this m becomes 1. So what remains? Minus of xi plus 0, right? So it is minus of xi. Okay, so further let us simplify this. We get, let me take minus sign out, 2 out. So minus 2 by n, summation I goes from 1 to n. So over here I get xi into, again let me, put over here y hat in order to simplify it, because this is nothing but y hat. Okay, so here we have simplified. So this is derivative with respect to m. Okay, let us do the same with respect to c. So it is d by dc equals to, suppose I also call it as dc, 1 upon n summation I goes from 1 to n 2 into yi minus. Okay, here I have mxi plus c, okay, into into. Now the c becomes 1 because we are computing with respect to c. It becomes 1. So what I shall have over here? Minus sign, minus 1. Okay, so simplifying the derivative further, I get minus 2 by n summation I goes from 1 to n. Okay, what do we have over here? Yi minus y hat. Okay, so we have simplified dm as well as dc. This is our step 2. Okay, now what we need to do in our step 3? After computing derivatives, we need to modify, alter, update our values. Okay, update values. Which values we need to update? Of course, m as well as c. Okay, so let us see how to update. M equals to m. Okay, my older value of m minus my learning rate into dm, derivative. Okay, where this is called as step size. Okay, it's called as step size. And the other one is c equals to older value of c minus learning rate into dc, where again this is called as step size. Okay, so further let us see what is step size. But before that, I would also like to state my final step. What we have to do, what we have to do. So here I'll simply say that we need to repeat this process. Okay, repeat the above process. Okay, process, steps 2 and 3 we need to repeat. Why or how long? We need to repeat till our MSc gets minimum, till our MSc reduces. Okay, or simply what we can do is we can start with assuming certain number of iterations. Okay, suppose I say iterations equal to 1000. So for 1000 times I need to repeat it. Okay, or and always while repetition I have to check that whether my MSc is reducing or not. My final aim is my MSc should be least or minimum. Okay, so further let us concentrate on what do you mean by this step size. Okay, so what is this learning rate and what is this step size? Imagine that a person is standing at the top over here of the slope. Okay, and I have certain notations. Fine. So what is my m? M is current position of that person. Okay, m is nothing but current position. Then I have, what is d? D is steepness of the slope. Steepness of slope. Fine. Then I have L. Okay. L, we call it as speed of moves. Speed of moves taken by the person. Okay. And I have new value or new position of that person equal to old position minus the speed of that person multiplied by steepness of the slope. Okay, so this L and D, it is nothing but size of step. Size of step. Okay, so in order to go to the new position, so old position minus size of a step. Okay, so suppose I have that my slope is steep. Okay, value of D is high. That means my slope is steep. Okay, so what will happen in this case? I can say L into D also will be high. So what that person has to do, he has to take longer steps. Okay, you can check here in this at this position, my slope is steep. So that person has to take large steps. Okay, whereas what if value of D is small? Okay, value of D is small. That is slope is less steep. Okay, so in this case, my L into D, that is a step size, will be smaller. So you can check over here, his step size are smaller. Okay, and finally, this is his goal position. So I hope L into D is clear, right? So we need to assume L value of L, right? So over here we have assumed 0.001. So as I said, For better accuracy, this value should be small. We can, change the value by trial and error method. Okay. Further, okay, what if, what if longer steps are taken or very shorter steps are taken? Let me comment on that point also over here. Okay. So suppose this is my MSE. Okay. Suppose I have plotted it against M, and and it starts from over here. Okay. So suppose we have taken longer steps. So what has happened, because we have taken longer steps, it came over here, and from over here it directly went over here. So this global minima point is skipped out. It didn't reach to global minima at all. Okay, due to longer steps, our global minima is never reached. Okay, so this is the case where my L is too high. Okay, L is too high. Because of this, global minima got skipped. Okay, there could be the other case where my L is very low. Okay, where my L is too low. Now what should happen in this case? Let us see. Okay, so again we have plotted M and MSE. So in this case, if my L is very small, what will happen? My step size are very small. I'll reach global minima, but it will take lot of time. It takes time to reach to global minima, and hence our convergence is slow. Okay, so a proper value of L has to be selected. Okay, so I hope it's clear. Now let us do one example. Mathematically, let us see how all this is going to work. Okay, so for that we need one vector x. Suppose it is values of it are 2, 4 and 5. We shall do it mathematically and trace whether really our MSE reduces. 1.2, 2.8 and suppose it is 5.3. So we have three values over here. Okay, it's 5. Fine. So let us assume our learning rate point not 1. Okay, for example, I've taken it as point not 1. Okay, then let us assume our C value. C value also can be written as beta 0. Okay, few people denote it using beta 0. So suppose it is 0 I have taken, and let me assume M value, which is written as beta 1. Let us assume it to be 1. Okay, so then what is the first step we have to do? Okay, so we have assumed the things. This was our first step. Second step, what we need to do is to go for derivative and all. So for x, okay, y value is already given to us. Let us find what is y hat value. What is y hat value? For that we need equation. So using these values, what is our equation? Our equation is y hat equals to m, that is 1, into x plus c, which is nothing but 0. So using this equation, I have to write down the values of y hat. Okay, so what is x? 2. What is next x? 4. What is next x? 5. These values they have given us. So I'll write down it over here, 5.3. And we need to find out, put 2 in this, x as 2 in this equation. What do you get? Y hat? Y hat is nothing but 2. Put x equal to 4, we get it as 4. Put x equal to 5, we get it as 5. So these are the new y hat values what we have got it. Okay. So after getting y hat value, what we shall do is immediately we shall find out the cost. Okay, immediately let us find out the cost. So what is formula for our cost? We already know it. Okay, so let us simply do the calculations. So it is 1.2 y minus y hat bracket square, and this has to be done for every 2.8 minus 4 bracket square plus 5.3 minus 5 bracket square. And once if I do this, I have to average it, right? So what is the value of this? After computing, I get zero point 0.8 square plus 1.2 square. It's actually negative value, which after squaring it, it will become positive, right? Plus 0.3 square. Here also it will be minus 0.8 square. Okay, so solving this, we get it as 2.17. 2.17. What remains over here is averaging it, right? We for, here we need to MSE formula, right? So what does MSE formula says? We need to average the value, take mean of these values. So what is the error that I get it over here? What is the cost that I get it? 0.7233. Okay, this is the initial cost what I have got it. Now, what is my next step? When I have this, I have to find out the derivatives. So we need to find DC as well as we need to find DM. Okay. So what does DC and DM, what we have to do for it? Minus 2 divided, sorry, 1 second now. 2 upon n. What is my n? My n is 3. Okay. So here we need to go for subtraction of 1.2 minus 2, right? Plus y minus y hat, right? 2.8 minus 4 plus 5.3 minus 5. Okay, so we need to compute this. So after putting all the values, we get it as 3.4 divided by 3. And what is my value? Final value, I get it as 1.133. This is value for my DC. Secondly, let us compute DM. Again, it's minus 2 by 3. And now what I need to do with these values, I need to multiply x, right? So I get 2 into, actually I'll compute it over here. What is the value? Minus 0.8. Same value, just I need to multiply x in it, right? So plus, what is next x? Next x is 4. Okay, minus of 1.2 plus next x is what? 5 into 0.3. Okay, so on solving this, I get my DM value as 9.8 by 3, which is 3.2667. Okay, so we found value for DM as well as value for DC. Now what we need to do into our third step, we need to update the values, right? So our value for beta 0, new value for beta 0, I denote it using t plus 1 equal to older value of beta 0. Beta 0 means only what? C, right? So here, older value of beta 0 minus learning rate multiplied by DC. Okay, so let us do it. What is my older value of beta 0? It's 0 minus 0.001 into, what is the value of DC that we have just found? 1.133. So when I do this calculation, I get answer as minus of 0.01133. Okay, this is the new value of beta 0 what I have found. Then similarly, let me find value of beta 1, that is nothing but new value of my m. So old value of m minus L multiplied by dm. Okay, this is what I have to do. Now, what is my older value? 1.001 into, what is my dm? It is 3.2667. Okay, so on computing this, what is the value that I get? I get 0.996733. Okay, so I found both the values. What is further we need to do? Okay, further we need to write down the equation. Let me continue it on our next slide. Okay, we get the equation as y hat equals to, okay, 0.99673x minus 0.01133. Okay, this is the equation that we have got. Further, we need to repeat the same steps, okay, the way we have done. Okay, let us do for a moment. Okay, what is x, y, what they have given, and y hat, but now y hat you have to compute using this equation. What is value of x? We have 2, 4 and 5. What is value of y? They have given 1.2, 2.8 and 5.3. Okay, so simply by using this equation, I mean put x equal to 2 in this equation, find out what is value of y hat. We get it 1.99233. Okay, put x equal to 4 in that equation. What is the value of y hat that you get? 3.98. It is 3.9857. Okay, put x equal to 5 in that equation. You get y hat as 4.9825. 3. Okay, this is the value. Now purposefully I've done this so that we can compute the cost and we can check whether really our cost has reduced or not. Okay, so I mean have to compute our cost. Okay, 1.2 minus y hat, right? 1.9923, right? Square plus second cost 2.8 minus 3.9857 bracket square plus, okay, what's next? 5.3 minus 4.98253 bracket square, and when we get this we need to divide it by 3, right? Take its mean. So on solving this, okay, on solving this for our cost, I'll directly, I mean, write down, we get 2.1335 divided by 3. So what is our cost? We get it as 0.711. This is the value of cost that we have computed. Okay, and if we will check what was our previous cost, okay, we had also computed cost over here, right? So what was our cost? 0.7233. Okay, and now the cost is 0.711. So our cost has reduced. Okay, our cost has reduced. So now further what we need to do is, after doing this, you can check after cost what did we do? We went for DC, we went for DM. Okay, so again in the same fashion, using these things, we need to find out DC once again. Okay, for this iteration we need to find DC. Okay, so I'll simply write down the values. We have to perform it in the same way what we have done. Okay, this time we have to use these values of y hat, okay, because it is our new iteration. So what value of DC do we get after our computations? We get it as 1.107. Okay, and what is the value of DM that we get after these computations? We get DM as minus 0.002224. Okay, we get these as our values of DM and DC. So after this, we again need to update, right? So update the value for beta 0. Okay, so for that we need to take the older value of beta 0, right? What is our older value? That is our previous iteration values, right? Not 1133 minus, what is my learning rate? Not 1 into what is my DM? Sorry, DC, right? DC, because we are manipulating beta 0, that is nothing but C. So after computing this, right, what do I get? My beta 0 is minus 0 point new value. Okay, I get 0.002244. Okay, and I'll also modify the value of beta 1 at my, so my previous value of beta 1, what is my previous value of beta 1? 0.996733 minus 0.001 into. Okay, what is my, I mean, I need to multiply DM in it, right? So what is value of DM with me? One second. One second, guys. One calculation here. This is wrong. I'll just cut it and I'll put proper value of DM after calculations. We get DM as 3 point, I'll write down over here, 3.15993. Extremely sorry. Okay, so that dm value we will be putting it over here, 1993. Okay, yeah. So after solving this, what we get is 0.99357. Yeah, just by mistake I had written this value. So actually after computations I got dm as 3.1993, so that the same value I have put it over here and I got the correct value for my m new value. Okay, so in this way what would be our next step then? Again we got a new equation. Okay, so we will write down the new equation of y hat. Okay, so after what would be our equation? 0.99357, right, minus 0.00224, y equal to m into x. So my x will be over here, y into mx plus c. This shall be my new equation, right? So I mean, then again we need to compute error, right? Cost function. So the cost function what we get further is 0.7005. So if you will check, cost function is again reduced. Okay, previous was